Hello and welcome back to another video. In this video we're going to be going through my TUT 5 and we're going to be going through increasing and decreasing annuity examples. Let's get to the first question. Okay, so question 1 says Matthew makes a series of payments at the beginning of each year for 20 years. The first payment is 100 Rand. Each subsequent payment through the 10th year increases by 5% from the previous payment. After the 10th payment, each payment decreases by 5% from the previous payments. Calculate the present value of these payments at the start of at the time the first payment is made, using an annual effective rate of 7%. Okay, so let's start by drawing a timeline. So we'll have our timeline like this. It'll go from time 0 to time 20 because it's for 20 years. Okay, and it says the big payments are made at the beginning of each period, and the first payment's 100. So at time 0 we'll pay 100. Okay. Now let's think about how much we pay at time 1. So it says each subsequent payment increases by 5%. So basically the first 10 payments, they each increase by 5% each time. So at time 1, it'll be 100. And to increase by 5%, we're going to multiply by 1.05. Okay. Then at time 2, we're going to increase that by 5%. So it's going to be 1.05 to the power of 2. Okay. And you can see the pattern here. And it's for the first 10 payments. But since the first payment is at time 0, the 10th payment will be at time 9. And it'll be 100 times 1.05 to the power of 9. Okay, so these are our first 10 payments. And then it says after the 10th payment, each payment decreases by 5% from the previous payment. Okay, so now let's think about what we have to do here. So if it decreases by 5%, so then at time 10, to decrease this by 10%, it'll be 100 multiplied by 1.05 to the power of 9. Okay, so now we're basically just taking the previous one. But now we need to multiply it by something to decrease it. So we're going to go multiply it by 0.95. Because when you multiply something by 0.95, it decreases it by 5%. So that much how much the 10th payment will be. And then this goes all the way up until the time 19. Yeah, so it goes all the way up until time 19. And then at time 19, it'll be 100 multiplied by 1.05 to the power of 9, multiplied by 0.95, because we have to decrease by 5% each time, and we're decreasing it 10 times. So it's the power of 10. Okay, so this is the payments at time 19. Yeah, so these are the next 10 payments. So from 10 to 19 is 10 payments as well. And then we basically want the value at time 20. So let's write out what our present value formula will be. So we're going to say present value. It's going to be 100 plus, basically we're going to add them all up and we're going to discount them all to times 0. So it's 100 times 1.05, and we have to times this by v, remember, because we're discounting it by year. Okay. Now for the next one, it's going to be 100 times 1.05 squared times v squared. Okay. Plus plus, and then the last one will be 100 multiplied by 1.05 to the power of 9 times v to the 9, because this one we have to discount 9 years. Okay, so that's kind of our first pattern. And now that's our first 10 payments. Now we need to do our second 10 payments. So our second 10 payments will be 100 times 1.05 to the 9 times 0.95 times v to the 10, because we have to discount that one 10 years, plus 100 times 1.05 to the power of 9 times 0.95 to the power of 2 times v to the 11. And this pattern continues until it eventually ends 1.05 to the power of 9 times 0.95 to the power of 10 times to the power of 10 times v to the 19. Okay. Yeah, so that's basically how, that's our whole equation of value. And now we want to kind of simplify this so we can use annuity formulas. I can immediately see that here we can factor out 100, right? Because each of these in the first pattern has a 100 at the beginning. So when I factor out 100, it's going to be 100, and when I write it, it's going to be 1 plus 1.05v times v plus 1.05 squared times v squared, and that's going to continue until it gets to 1.05 to the power of 9 times v to the power of 9. Cool. Okay, so that's our first pattern. And then in the second one over here, I can see that I have 100 and I have a 1.05 to the power of 9 in each of them. So I can factor out that. So I can factor out 100 and I can factor out a 1.05 to the power of 9. Okay. And then we're also going to want to factor out a v to the 9 because that's common in all of them. And we kind of want this v power to match this 0.95 power. And you'll see later why. But let's just also factor out a v to the power of 9. Okay. And then we're going to be left with 0.95 times v plus 0.95 squared v squared going all the way up until 0.95 to the 10 v to the 10. Cool. Okay. So now that we've done this, we can notice that this looks a lot like an annuity in advance, and this looks a lot like an annuity in arrears. And that's exactly what it's going to be. So basically, this is going to be 100 times an annuity in advance for 10 periods. And we'll just say the rate is J. I'll show you how we're going to work out J later. Okay. Plus 100 times 1.05 to the power of 9 times v to the 9 times an annuity for 10 periods at an interest rate at a rate of K. Okay, so now we need to see how you would work out J and K. So the way I think about this is normally when you have an annuity, this is just going to be like v squared and then blah 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 v to the 9, for example. But now we have like two things. So we're going to say to get J, it's going to be 1 over 1 plus J is going to be equal to it's going to be equal to this basically. So it's going to be 1.05 over, and remember v is like 1 over I, and in this question I was 7%. So it's going to be 0.07. So basically we're letting this equal to that. Okay. And then we can easily just solve for J. We just flip both of them -1. So therefore J is going to be around 0.02. And I'll store this as A for accuracy in my calculator. And we'll use that later. Okay. So that's J. So that's the interest rate we're going to be using for this one. So now we want K for this one. So we're going to do exactly the same thing. So 1 over 1 plus K is going to be equal to that basically. So it's going to be equal to 0.95 divided by 1.07. Cool. Therefore, K is equal to 0.126, which I will store as B in my calculator for the future. Perfect. So now the present value, we said it was 100 times an annuity in advance at J. So that's going to be 1 minus 1 plus A to the power of -10 all over, since it's in advance, we have to do 1 minus 1 plus A to the power of -1. Cool. Now I need to do this part. So plus 100 times 1.05 to the power of 9 times 1.07 to the power of -9. Let me put like times in here. Times, so now we need the annuity formula in arrears. I'm just going to shift this over to give me some more space. So it will be 1 minus 1 plus, and remember at a rate of K, so I'm going to use B. It's the -10 all over B. Okay. And when you plug this into our calculator, I get 1,384.65, and that should be your final answer. Okay, now let's have a look at question B. So B says, in return for a single payment of 1,000 Rand, a building society offers the following alternative benefits: a lump sum of 1,330 Rand after 3 years, a lump sum of 1,550 Rand after 5 years, or 4 annual payments, each of amounts 425, the first payment being made after 5 years. An investor must specify which benefit he is choosing when he makes the single payment. Write down an equation of value for each saving plan and hence to find the yield for each. Okay, so let's start with the first one, so I. Okay, so let's draw down a little timeline to show what the cash flows are. So we're going to start at time 0 and we're receiving after 3 years. Okay, so we're buying it currently, so we're buying it for 1,000 Rand, so it'll be minus 1,000. And then after 3 years, we're going to be getting 1,330. Okay, So this should be pretty easy to work out the yield of this one. It's basically just going to be 1,000, then we're just going to present value this one and equal it to 1,000. So 1,330 multiplied by 1 plus I to the power of negative 3. We solve for I here, therefore I is equal to 9.9724%. Okay, that's pretty easy to work out. So that's for the first one. Now let's have a look at the second one. So the second one, a lump sum of 1,550 Rand after 5 years. Okay, so it's very similar to this one, but now we're getting more money, but at a later date. So we are at time 0, we're paying 1,000, and then at time 5, we're going to be receiving 1,550. Cool. So we just have to present value that and let it equal to 1,000. So 1,000 is going to be equal to 1,550 multiplied by 1 plus I to the power of negative 5. And therefore, if you plug this, if we like solve this using our calculator, we're going to get I is 9.161%. Okay, another pretty easy one. Number 3. 4 annual payments, each of amount 425, the first payment being made after 5 years. Okay, let's draw a timeline for this one. So we're going to say that we're going to start at time 0 and we're going to buy it for 1,000, and it basically says we're getting four payments of 425 after 5 years, so at time 5, time 6, time 7, time 8. So let's draw in our times. So we'll have time 5, time 6, time 7, and time 8. And at each of these, we're getting 425. 425 plus 425 plus 425 plus 425. Cool. Okay. So the way we write an equation of value is we're going to want to present value all of these. So we're going to say 1,000 is equal to 425 multiplied by 1 plus I to the negative 5 plus 425. Now it's that present value, that one. Now we're going to do the next one. So multiplied by 1 plus I to the negative 6 plus 425 multiplied by 1 plus I to the negative 7. And then finally the last one, 425 multiplied by 1 plus I to the negative 8. Okay, so we could solve this using linear interpolation, but that's going to take quite a long time. So instead, I'm going to show you how to do it using the financial calculator. Okay, so this is the financial calculator. I got a picture just so I can show like which buttons you push. So we're going to enter all these cash flows in. So let's start with this cash flow. So our first cash flow is negative 1,000. So step number 1, we're going to say cash flow 0 is going to be negative 1,000. Okay, so the way you enter this into your calculator is you're going to do you're going to enter 1,000 using the numbers, and then you're going to use this change sign to make a negative, and then you're going to press G and this one because it says cash flow 0 in blue there. So that's how you would enter negative 1,000 as your cash flow 0. Okay, and now we can see at time 1, 2, 3, and 4, we're going to have cash flows of 0. So the way you'd enter this in, so step number 2, you'd say cash flow J is equal to 0. So the way you do that is you'd say 0 and then G and then this one. Sorry, not this one. So you say 0, G, and then this one because this is cash flow J. Okay. So that basically says that the next cash flow is 0, but we want the next 4. So if you want 4 cash flows of 0, step number 3, you would say NJ equals 4. So you would press 4 and then G and then NJ here. So that basically says the next 4 cash flows are all 0. Okay, so that sorts out all those zeros. And now we have the next 4 cash flows of 425. So the way you would do that is you would say cash flow J equals 425. So you'd type in 425 and then G cash flow J. And then again, we would say NJ equals 4 because we have 4 cash flows of 425. So you'd type in 4 and then G and then NJ. Okay. And then to get your final answer, we would say, we'd find the internal return. So to do that, you'd get F, and then you'd press this button because it says internal return in orange at the top. And we'd get our internal return to be 8.5766. Okay, I hope that all made sense. And now we must just finally answer the question, because the question says he must choose one of these, right? So he's going to choose the one with the highest yield. So let's have a look. For the first one, it has like 9.9. Next one's around 9.1, and then 8.5. So our final answer would be he's going to choose the first option. So he would choose option I, because it has the highest yield. Okay, and that's all for this question. Now we're going to be having a look at question 2, and in question 2 we have to do a proof. So question 2 says, prove that partial derivative in terms of delta of an is equal to the negative increase in annuity for n years. Okay, so I think let's start by defining what delta is. So we know that delta is the natural log of 1 plus I. Okay, so we can use this, if we raise both sides to the power of e, we can use this to show that 1 plus I is e to the delta. And once again, if we move the 1 over, we can show that I is equal to e to the delta minus 1. Okay, so basically we have to do the partial derivative of an annuity in arrears. But when I think of the annuity in arrears, I think of this formula. I think of negative 1 plus I to the negative n over I. Okay, and the problem is this doesn't have any deltas in, so it's going to be hard to do the derivative in terms of deltas. But what we can do is we can use this to now sub in deltas so that we can do the derivative. So we can write it like 1 plus, and we showed that 1 plus I is equal e to the delta, so this will become e to the negative delta n over, and we show that I is going to be equal to e to the delta minus 1. So we can write this as e to the delta minus 1. Okay, so now all we need to do is do the partial derivative of, so in terms of delta, so it's going to be, we're going to use the quotient rule here, so we're going to have to do the derivative of the top times the bottom, so it's going to be n times e to the negative delta n times the bottom, so e to the delta minus 1, so this is basically derivative of the top times the bottom, minus, now we need to do the top, so 1 minus e to the negative delta n times the bottom. Derivative of the bottom is just going to be e to the delta, and this is all going to get divided by the bottom squared. So it's going to be divided by e to the delta minus 1 squared. Cool. Okay, so now it's a bit hard to see how we manipulate this to look like that, basically. But I think what we can start with is we can basically write this formula out and then put it in terms of deltas, and then that'll help us to see where we're going. So negative increase in annuity for n years. So all we have to do because we have this negative is we're going to swap the top. So it's basically going to become NVN minus annuity in advance for n years divided by I. Okay, and now all we need to do is do the same thing as before, is we're going to use these like 1 plus I, we're going to sub it in here, and we're going to use I, we're going to sub it in here. Okay, but first let's just expand this one. So this expands to minus 1 minus 1 plus I to the negative n over 1 minus 1 plus I to the negative 1. This is all going to be divided by I. Okay, so if we sub in like for deltas and stuff, it's going to be n times n, because v is 1 plus I to the negative 1, and we know that 1 plus I is e to the delta, so this will become e to the negative delta n minus 1 over 1 plus I is e to the delta, so e to the negative delta n over 1 minus e to the negative delta. And this is all divided by I, and we know that I is e to the delta minus 1. Cool. Okay, so this is basically where we're trying to go to. So now we want to manipulate this thing so that it looks like this. So the first thing I notice is that we can split it up, and then this will cancel with that. Okay, so let's just write what we're doing. So we're saying partial delta of your annuity is going to be, so I'm going to cancel basically that and one of those. So it's going to be n times e to the negative delta n divided by e to the delta minus 1. Okay. Minus, and now I'm just going to have to keep the other thing the same for now. 1 minus e to the negative delta n. I'm actually going to, yeah, just keep it the same for now. So e to the delta minus 1 squared. Okay. Now I'm going to split it up and write it in a certain way, and you'll see why I do that. So we have n e to the negative delta n over e to the delta minus 1 minus e to the delta multiplied by 1 minus e to the negative delta n over e to the delta minus 1 times 1 over e to the delta minus 1. Okay? I hope you're, let me just, because this isn't in the exponent, this is down, let me just write that nicely. E to the delta minus 1. Okay? And now what I'm going to do is from this bottom, I'm going to factor out an e to the delta. So this is going to become n times e to the negative delta n over e to the delta minus 1 minus e to the delta 1 minus e to the negative delta n over e to the delta. So I'm going to factor out, so this becomes 1. And then when we factor out an e to the delta out of 1, it's going to become e to the negative delta. Okay? Times 1 over e to the delta minus 1. Okay? And we can see that that and that cancels. And now we can combine it all as one fraction because they have the same denominator. So basically this is all over that. So we can write it as n e to the negative delta n minus 1 minus e to the negative delta n over 1 minus e to the negative delta, all divided by e to the delta minus 1. Okay? And the great thing is now we can see that that looks exactly like that, right? So we just prove that this is all equal to the negative increasing annuity for n years. And that's question 2. Okay, so now let's have a look at question 3. So question 3 says, an annuity is payable for 20 years. The amount of the annuity in the tth year is RT squared. On the basis of an effective rate of interest of 5% per annum, find the present value of the annuity, assuming that it is payable, and then for A we have to do annually in advance. Okay, so basically, whatever the year is, you pay that squared. So let's draw a little timeline to represent this. So, so you have 0, 1, 2, blah, 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 going all the way up until the 20th year, so 1920. Okay, so this period is the first year, and here we'd pay 1 squared, which is like 1. And it says it's paid annually in arrears, so here we'd pay 1. So here in the second year, we'd pay 2 squared, which is 4, and then 9, and then let me just do like times 3 as well, we'd pay 16. Okay, cool. So then obviously at time 19, we'd be paying for the 20th year, so we'd be paying 400. Okay. So how would we find the present value? So basically all we'd do is bring all these amounts to time 0. So the present value would be 1 plus 4 times v, because you're present valuing it, times 9 times v squared, plus 16 times v cubed, plus all the way up until 400 times v to the 19. Okay. So here we're going to use a little trick where we're going to take this equation and we're going to multiply both sides by v, and you'll see why I do this later. So v times the present value, it'll be, let me write it in a certain way, so it'll be v plus 4v squared plus 9v cubed plus da da da, all the way up until, so it'll be plus like 19 squared times v to the 19 times 20 squared plus 20 squared v to the 20. Yeah, okay. So now what we can do is we can say, I'm going to say this one minus this one, okay? So I'm going to say the present value minus v times the present value is going to be, and as you can see when we subtract it, okay, this one will just be on its own, so it'll be 1 plus, and now we just do 4 minus 1, which is 3v, right? And this will be 9v squared minus 4v squared, which will be 5v, okay? And it keeps subtracting like that, and it always increases by 2, so 3v, and then plus, sorry, it's 5v squared plus 7v cubed plus blah 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 plus, and then it goes all the way up until 39v to the 19, and at the end there's no v to the 20 in this one, so that's just on its own, so minus 20v to the 20. Okay. And now we can write this in a certain way, so that we can write it as a sum of an annuity and an increasing annuity. Okay. So the way I'm going to write it is I'm going to write it as 1 plus v plus v squared all the way up until plus v to the 9, let me just do the dots, plus v to the 19. Okay, so basically what I've done is I've taken like kind of like 1 out of all of these, and then if I factor out a 2 out of the rest, so now we're left with like 2v, 4v squared, 6v cubed. If I factor out a 2, it's just going to be v plus 2v squared plus all the way up until plus 19 v to the 19. Okay, and then at the end we still have our last term, which is minus, sorry, this is 20, this is supposed to be 20 squared, yeah, minus 400 v to the power of 20. Okay, and now let's look at what each of these individual things looks like. This looks like an annuity in advance, right? So this is an annuity in advance for 20 periods, okay? Plus 2, and then in brackets, this part looks like an increasing annuity, right? So this is going to be an increasing annuity for 19 periods. Okay, and then I'll, well, let's just look like that, and then our last thing we just keep the same, 400 times v to the 20. Okay, so, but remember, this isn't our present value, this is present value minus v. So if we want to find our present value, we can just factor our present value. We're going to get like 1 minus v, and then divide both sides by 1 minus v. So I'll say, therefore, our present value, it's going to be all of that over 1 minus v. So it'll be our annuity in advance for 20 years, plus 2 times an increasing annuity for 19 years, minus 400 v20, all divided by 1 minus v. Cool stuff. Okay, so now we just need to work out each of these components individually. So let's start with this one. So an annuity in advance for 20 years, the formula is 1 minus 1 plus I, and I is 5%, yeah. 1.05 to the power of negative 20 over 1 minus 1.05 to the negative 1. Good stuff, okay? And then when we type that into our calculator, we're going to get 13.09, and we'll store that as a, yeah, okay. So now we've worked out the first thing, so now we need to work out an increase in annuity for 19 periods. That'll just be this is the formula, minus NVN, so 19 times 1.05 to the power of negative 19 over I, which is 5%. Cool. When you type this into our calculator, we're going to get 103.41, which we'll store as B. And I think that's everything we need. So now to work out the present value, it's going to be A plus 2B minus 400 times 1.05 to the negative 20, all divided by 1 minus 1.05 to the negative 1. And this should give you 1,452.259126. And the reason I'm writing the decimals is because we're probably going to use this answer for B. Okay, so that's A. So now let's have a look at B. So that was annually in advance. So now B says continuously, the rate of payment being constant over each year. Okay, so now let's draw a timeline for what this kind of thing would look like. So now, instead of paying it at the beginning of the year, we're paying it continuously throughout the year. So I'm going to draw my number line, starting at time 0, ending at time 20. And let's put a few points, time 1, time 2, time 3. Okay, so between time 0 and time 1, we're going to be paying 1 rand per, continuously throughout the year. And then at time 2, we're going to be paying 4. And then here we're going to be paying 9. And then let's put time 19 on here as well. And then here we're going to be paying like 400 continuously. Okay. So the way we'd find the present value for this is we would do, to do like continuous for 1 year, you're going to multiply it by an annuity for 1 year. So like for the first one, it's going to be 1 times an annuity for 1 year. Okay. So that basically present values it to here. Now for this one, we're going to say plus 4 times an annuity for 1 year. But that basically present values it to here. So now we can still do it 1 more year. So I'm going to times it by V. Okay. And then some of the things, it's 9 times continuous, sorry, I should be writing a line above these. These are all continuous annuities. So that would be 9 times that would value it to here. So 2 more years back, so times it by V squared. And this pattern will continue until we get up until 400 times an annuity times V to the 19. Okay, cool, this has all been times together. Perfect. So now I can see that there's a common thing, which is this annuity, so I can factor that out. So continuous annuity for 1 year. Then we're going to get 1 plus 4v plus 9v squared plus 400 v to the 19. Okay, and this might look quite similar, right? This might look quite familiar. So let's have a look. Where have we seen this before? This looks exactly like this, right? So 1 plus 4v plus 9v squared plus 16v cubed. That's exactly the same as what's in this bracket. So this part is exactly going to be our answer that we just solved. So all we have to do is we have to sub in this for this bracket. So our present value is going to be, basically it's going to be this formula. So let's write out the formula. So it's 1 minus 1.05 to the negative 1, but remember it's continuous, so we need to divide it by delta, which is ln of 1.05, okay? And then we just need to multiply that by all the answer for the previous one, which was 1452.259126. Cool, that's all we need to do. Sub that into a calculator, and we get 1,417.4. And that's how you do question 3. Okay, now let's have a look at question 4. Question 4 says a loan is repayable by a decreasing annuity payable annually in arrears for 20 years. The repayment at the end of the first year is 6,000 and subsequent repayments reduced by 200 Rand each year. The repayments were calculated using a rate of interest of 9% per annum effective. Calculate the original amount of the loan. Okay, so let's start with a timeline. So it's going to start at time 0 and it's go up until time 20. And we'll have like time 1, time 2, time 3 going on it. And let's draw in time 19 as well. So it says the first payment is 6,000, so that'll be at time 1. And then it decreases by 200, so it'll be 5,800, 5,600. And if you work it out at time 19, it'll be 2,400, and then 2,200 at time 20. Okay, so to work out the present value, what I like to do, so this is a decreasing annuity, so I sometimes struggle to remember that formula, but I know the increasing annuity formula. So what I'll do is I'll say 6,200 times an annuity for 20 years. So this basically assumes we're paying 6,200 throughout. And then what I'll do is I'll subtract an increasing annuity of 200. Increasing annuity for 20 years. So basically what that means is that in the first year, it'll be 6,200 minus 200. In the second year, it'll be 6,200 minus 400. And then going on, so this will be 6,200 minus 600, and that'll actually be exactly the same as this. Okay, so now all we need to do is work out these things. So annuity for 20 years is going to be 1 minus 1.09 to the negative 20 over 9%. And if we plug that into our calculator, we will get 9.1285. And I'm going to store that in my calculator as A. Okay. And now we need to work out what the increasing annuity for 20 years is going to be. And the formula is going to be 20 minus 20 times 1.09 to the power of negative 20 over 9%. Obviously, we'll have to work this out separately, but if we do all of those calculations, we're going to get 9.1285 for this. I'll store that in my calculator as B. So then basically the present value of all of these, which is the loan amount, the outstanding balance at time 0, which is the amount of the loan, is going to be, we just plug all our things in, so 6,200 times A minus 200 times B, and if we put that in, we're going to get 42,415.88, and that's the answer to question 4. Now let's have a look through question 5. So question 5 is quite a long one. It says a consortium is considering the purchase of a coal mine, which has recently ceased production. The consortium's forecasts that the cost of reopening the mine will be 700,000, and this will be incurred continuously throughout the first 12 months. After the first 12 months, the revenue from sales of coal, less the cost of sales and extraction, will grow continuously from 0 to 2.5 million at a constant rate of 250,000 Rand per annum. When the revenue from sales of coal, less cost of sales and extraction reaches 2.5 million, it will decline continuously at a constant rate of 125,000 per annum until it reaches 250,000. When the revenue declines to 250,000, production will stop and the mine will have zero value. Okay. Additional costs are expected to be constant throughout at 200,000, excluding the first year, and these are incurred continuously. What price should the consortium pay to earn an internal rate of return of 20% per annum effective? Okay, so what we're going to have to do here is we're going to have to find the present value of all these different cash flows, and that's going to be, and we're going to discount them all at 20%, and that's going to be basically the price they should pay. So I think a good first step here would be to draw a timeline, because there's quite a lot going on. So it goes from time 0 up until time, okay, we're not sure exactly when it ends, but we'll figure that out. So it says basically for the first 12 months, for the first year, we have costs continuously, and for the whole year it's 700,000. Okay. And then it also says for the rest of it, after year 1, we have 200,000 costs, which are also continuous. So 200,000 Rand per year. So 200,000. Okay, those are all our costs. Okay, and then it says that from time 1, revenue grows. Where is it? Here. Revenue grows continuously from 0 to 2.5 million at a constant rate of 250,000 Rand per annum. Okay, so if it starts at time 1 and it grows to 2.5 million at this rate, it's obviously going to take 10 years, right? Because 10 times this will give you that. So that'll grow basically until time 11, and it grows continuously. So I'm going to represent that with a solid line that grows like this. Okay, so that's going to grow continuously up until that point here, and this point is going to be at 2.5 million. Okay, and then it says it declines at 125,000 per annum until it reaches 250,000. Okay, so to work out how many years it's going to decline for, we can take the peak, which is 2.5 million, minus 250,000. That's going to give us 2,225,000. And if we divide that by 125,000, we get, let me just work it out, we're going to get 18, right? So that's going to give us 18. Okay, so that means it's going to decline for 18 years. So that means our mine's going to close after 29 years, because 11 plus 18, okay? So basically then it's going to decline. And it's not going to reach 0 because it says it reaches 250,000. So basically this is 250,000. Okay, so those are all our cash flows. Now we just need a present value of those. So let's write an equation of value. So our present value is going to be, let's start with the incomes. So it's going to be 250,000 times an increasing annuity, but it's increasing constantly for 10 years. And that'll discount it to time 1, but we want to discount it to time 0, so you have to multiply that by V. Okay. Our next one is this decreasing one. So what I'm going to do is I'm going to assume that it's continuous at 2.5 million, and then we're going to subtract an increasing annuity, which will kind of slowly lower it. So I'm going to assume that it's going to be at 2.5 million, and I'm going to say that's constant. So I'm going to multiply that by a constant annuity for 18 years. But then we have to subtract it by an increasing annuity, which is increasing at 125,000. 125,000. And that's also going to be for 18 years, right? That's going to discount it to this time point. So then to get to time 0, we just need to discount it by another 11 years. So times v to the power of 11. Okay. Now let's deal with the expenses. So we have an expense for the first year at 700,000. So this one should be quite easy. We're going to subtract 700,000 times a continuous annuity for 1 year. And then this 200,000 is going to be minus 200,000 times an annuity continuously for, so that's going to be 28 years. And that's going to discount it to time 1. Now we just need to go 1 more year, so times v. Cool. So now let's work out what each of these individual things are. So let's start with, maybe let's start with this, the increasing annuity, okay? So the formula for this, for 10 years, is going to be, so we need a normal annuity for 10 years, which is continuous, minus 10 times v to the power of 10, divided by the natural log of 1 plus the interest rate, which is 20%, so 1.2. Okay, so now we just need to work out this thing. So continuous annuity for 10 years, the formula is 1 minus 1 plus I, so 1.2 to the power of negative 10 over delta, which is the natural log of 1 plus I. And if we plug that into our calculator, we're going to get about 4.6. Okay, so let's store that in our calculator as A. Now we can work out our increasing annuity for 10 years. And that's going to be basically A minus 10 times 1.2 to the power of negative 10, all divided by the natural log of 1.2. Cool. And when we sub this into our calculator, we're going to get 16.37, which I'm going to store as B. Okay. So that's this thing checked off. Now we need to do this. So let's work out what a continuous annuity for 18 years is. So continuous annuity for 18 years, it's going to be 1 minus 1 plus I to the power of negative n over delta, which is natural log of 1.2. Okay, that's going to give us 5.28, and let's store this as C. Cool, so we've got this now. Now we just need to work out this. And this is also decreasing continuously, so it should have a line above. Okay, so an increasing annuity for 18 years continuous is going to be C minus 18 times 1.2 to the power of negative 18 over ln of 1.2. That's going to give you D. Cool, so now we've got that. So now we just need that. So continuous annuity for 1 year. Continuous annuity for 1 year, pretty simple. It's just going to be 1 minus 1.2 to the negative 1 over ln of 1.2. And that's going to give you 0.91. Let's store this in our calculator as F. And then finally, we just need this, continuous annuity for 28 years. Continuous annuity for 28 years is going to be 1 minus 1.2 to the negative 28 over ln of 1.2. And that is going to give us 5.45, which we will store as E. Okay, so these are all just pretty simple calculations, kind of just using the formulas. And now all we need to do is sub all of these things that we just worked out into our formula. So present value, which is the price, is going to be, so it's going to be 250,000 times the increasing annuity for 10 years, which was B, right? So it's going to be 250,000 times B times, but remember we have to discount it further a year because it's only going to present value to time 1, so we still need to do another year. So we need to times that by 1.2 to the negative 1. Okay, and now we're going to add, now that's like the increasing portion, so now we're going to add the decreasing portion. So it's going to be 2.5 million times, so 2.5 million times, let's just check, yeah, times our continuous annuity for 18 years, so that's going to be times C minus 125,000 times D, which was our increasing annuity for 18 years. Cool. But that present values it to time 11. That present values it to here. So we need to discount it another 11 years. So we need to multiply this by 1.2 to the power of negative 11. Cool. Okay, so now those are all our incomes. Now we just subtract our expenses, so minus 700,000 times this one, because it was only for 1 year, so times F, minus 200,000 times E, this was our continuous annuity for 28 years, but that discounted to time 1, so we discounted 1 more year. Okay. After all of that, if we sub this all into our calculator, we're going to get 212,611.11 Rand. And that's our answer for question 5. And that is the end of the TUT. I hope you enjoyed, and I'll see you in the next one. Goodbye.